One of the challenges of working in the sciences is that we are often called upon to deal with very big or very small numbers. For example, the distance from the Earth to the Sun is approximately 93 million miles. On the other hand, the distance between two carbon atoms in a typical molecule is about 0.00000000015 meters. Now this creates some challenges for us. How do we express these really big or really small numbers? How do we put them in our calculator? How do we handle them in a way that is not just really cumbersome? In order to do this, we use what we call scientific notation. Now, in order to help you understand the scientific notation, I'm going to start with a set of numbers. And you can notice that these numbers differ only in the location of the decimal place. I'm going to start with the number 10. If we start with 10, we could write that as 10 to the first power. Okay? If we have 10 to the second power, that is 10 times 10, or 100. If we have 10 to the third power, that is 10 times 10 times 10, or 1,000. Now, if we continue down, now this may be a little bit counterintuitive, especially if you do not have a lot of background in math, but anything to the 0th power is defined as 1. So 10 to the 0th power is 1. If we continue down, 10 to the minus 1 power is 1 over 10, or 0.1. Similarly, 0.01, is 10 to the minus 2. 0.0001 is 10 to the minus 3. So when we multiply by tens, we can move the decimal place one decimal over to the right. If we divide by tens or do 10 to the minus, we can move the decimal one place to the left. This is how we're going to use scientific notation. In general, what we're going to do with scientific notation is we are going to write a number. For example, if we have 3.14 times 10 to the second, this means 3.14 times 100, which means that we would move the decimal 2 places to the right, which would be the same as 314. And the exponent on the 10 is going to tell us how many places we need to move the decimal point. Let's look at some examples. First off, let's go from standard to scientific notation. Here we've got 137 billion joules, and we're going to want to write this in scientific notation. The way I'm going to do this is I'm going to start where the decimal place is, and then I'm going to count the number of spaces I need to move that decimal place. Let's see, 3, 6, 9, 10, 11. I'm going to move the decimal place until I only have one digit in front of the decimal. I'm going to rewrite this then as 1.37 times 10, and now my exponent is going to be the number of spaces I moved the decimal. I moved it 11 spaces, so I'm going to write this 1.37 times 10 to the 11th joules. Okay, pretty easy really. Here's another one, $25 million. I'm going to start with the decimal here. I want to end up with the decimal after the first non-zero digit. So I want this to be 2.5 times 10 to the something dollars. To find the something, I'm going to see how many spaces I need to move my decimal. I move it 3, 6, 7, so this would be 2.5 times 10 to the 7 dollars. Okay? If it's going to be a really big number, the exponent is going to be positive. If it's a really small number, we're moving the opposite direction, the exponent is going to be negative. So for example, here I need to move 1, 2, 3. I want to move until I'm just in front of the first decimal, so in front of the 3. So I'm going to write this 3.26 times 10, and now since I had to go towards the smaller, I'm going to write it as a minus. I had to move it 4 spaces towards the smaller, so 10 to the minus 4 centimeters. Let's do one more. I start here. I want to end up here. I've got to move it 1, 2, 3, 4, 5, 6, 7, I believe. 1.42 times 10 to the minus 7 grams. That's how we go from standard to scientific notation. If we want to go the other direction, if we want to go from scientific to standard, the process is just the opposite. So for example, here I've got 1.528 and I want to write it in standard notation. Well, what I'm going to do is I'm going to say, okay, I've got 1.528. It's times 10 to the 5th, which means I'm going to need to move the decimal 5 places. Now, which direction do I move it? Well, if it's 10 to the positive 5th, that means it's a big number. So to make it a big number, I would need to move it to the right. So I'm going to move it 1, 2, 3, and now to get it the rest of the way, I need to start adding zeros as placeholders. 4, 5. So my full answer would be 152,800, and then remember my units, kilograms. Here is the national debt as of around the end of 2012, 1.64 times 10 to the 13th dollars. So let's see if we can write this out. Now, I know that I'm going to go 1.64. I've moved 2 spaces already, so now I need 11 more zeros after that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. Okay, now I want to add some commas in. I'm going to erase the original decimal point, add some commas after every 3. There we go. That is what $16.4 trillion looks like. 2 more. Let's look at a couple where we've got negatives. 1.28 times 10 to the minus 7 millimeters. Okay. Now here I've got the minus 7, so this means this is going to be a very small number. Of course, this means I'm going to have a lot of zeros to the left of the 1. So I'm going to start with my 1.28, and then I'm going to move that decimal. I had to move it 1 spot. I'm going to end up moving it 7, so I'm going to need 6 zeros. 1, 2, 3, 4, 5, 6. And then the 0 there. So that would give me, let me make sure, 1, 2, 3, 4, 5, 6, 7. Yep, that gets me to 7 zeros, or 7 decimal places, and that's what the minus 7 means. Okay, again, I'm going to go 1, 3, 5. I have to move the decimal 1 spot, and then 2, 3, 4, 5 places to get to right there. So 0.0000135 ohms. That's how we go from scientific to standard. Now, one quick note about using a calculator for scientific notation. A lot of times people will make a mistake when they put this in. If you have a number that you want to put into your calculator, for example, 6.02 times 10 to the 23rd. This is a really significant number in chemistry, and so you'll put this in a lot. Now, typically there are 2 correct ways to put this in. One is to write it as 6.02 times 10, and then use the little caret button here, raised to the 23rd power. That is correct, but that's not the way that I'm going to recommend. The way I'm going to recommend is to use the button labeled either E or labeled EE. On my calculator, it's located as the second function above the x to the minus 1. The button will be labeled either E or maybe EE, or it might be labeled as EXP. And so if I want to put this into my calculator, what I'm going to do is put in 6.02, and then I'm going to press that E button, and then I'm going to put in 23. Now, when it registers in the panel, what I'm going to see in the panel is going to look like this, 6.02, and then I'm going to see a superscripted 23rd. This means 6.02 times 10 to the 23rd. Now, that's not how we would write it in everyday writing, but in a calculator panel, this is how it's going to show up. The important thing to catch here is that the E button means times 10 to the power. One of the most common mistakes that I have seen when people try to enter this in is they'll put in 6.02 and then they'll put in times 10 and then they'll type in the letter E and then put 23rd. This is wrong because the E means times 10 to some power. So what they've done is they've done 6.02 times 10 times 10 to the 23rd power, and they end up being off by a factor of 10. So make sure that you recognize that if you hit that E button, it means times 10 to the power, and that will help you quite a bit as you go through your calculations. One benefit of using scientific notation is that it allows us to clarify the number of significant digits. Earlier in this chapter, we looked at measurements like 100 million miles, and we talked about how it was not necessarily clear how much people were estimating these values. For example, is that exactly 100 million miles? Is that 100 million plus or minus 10? Is that 100 million plus or minus a million? It's not easy to see. It's ambiguous when it's written in standard notation. However, if we use scientific notation, we can clarify exactly what this means. If we write 100 million miles as 1.00 times 10 to the 8th miles, what we mean is that we know this number for sure, we know the next zero pretty sure, and the last digit, remember, we always have a little bit of uncertainty with it. So what this means is we've got roughly 1.00. It could be 1.01. It could be 0.99. So this is going to be right around 101 or 99 million miles. It allows us to express how precisely we know this number. If we knew this number more precisely, we might express it like this: 1.0000 times 10 to the 8th miles. So the scientific notation allows us to alleviate some of the ambiguity that we encounter, especially as it concerns big numbers.